Now, until now we have seen if 2 into 2 into 2 is written, it could be written as 2 raised to 3, or let me write it this way. 2 raised to 3 could be written as, what does it mean? 2 is being multiplied with itself. How many times? 3 times. So it will be 2 into 2 into 2. What is the value? 2 to the 4, 4 to the 8. Okay. If I write 2 raised to 2, so it will be 2 into 2, which is nothing but 4. If I try to compare it with my previous value, how did I get 4? If I divide 8 by 2. Okay. Similarly, if I have to write 2 raised to 1, it means 2 is coming how many times? 1 time. So the value is 2. Comparing with the previous value, so it will be 4 by 2. So as you can see, as I am decreasing the exponents by 1, the each next value is being obtained by dividing the previous value by 2. 4 is being obtained by dividing 8 by 2. 2 is being obtained by dividing 4 by 2. When is this happening? When you are decreasing the exponents by 1. By the same logic, if I have to find the value of 2 raised to 0, how I could find it? Whatever is the value of previous number, that I have to divide it by 2. So what do I get? I get it as 1. So each next number is half of the previous number. Why half? Because the base is 2. Let us take another example of 5. Suppose I am multiplying 5 into 5 into 5, or 5 cube could be written is like this. So it is 125. Similarly, 5 square, which is 5 into 5. So 125. The answer is 25. How do I get 25? So 125 divided by 5. Similarly, 5 raised to 1. So 1 time 5. How do I get 1 time 5? The previous value divided by 5. So I have get it 5. Similarly, 5 raised to 0. Whatever is the previous value divided by 5, and you get the value. So here also each next value is 1/5 of the previous one. Why 1/5? Because the base is 5. And here each next value is half of the previous one. Why? Because the base is 2. Okay. So from these two examples, we come to know the first value, or we can write a generic law which says a raised to 0 is always 1, where a can be any non-zero integer. Because here instead of plus, even if I take a number as negative, still I will be getting the same value as 1. Yes, so it says anything raised to 0 is always 1. This anything number can be any number other than 0. Okay, so I hope you understood the first value, or the first law, which says a raised to 0 equal to 1. How did we obtain? We have been decreasing the exponent by 1 each time, and whenever the exponent was decreasing, the same number which was being multiplied, we used to divide the previous value by that number. Okay, so now from this, let us see what is the value when the exponents are negative. Here the exponents are positive, here it is 0. Let us see what if the exponents are negative. So here 2 raised to minus 1. By the same pattern, when you are decreasing the exponent by 1, whatever is the previous value, divide it by 2. So it will be 1 by 2. Similarly, 5 raised to minus 1. Whatever is the previous value, divide it by 5. Why 5? Because the base is 5. Right? Similarly, 2 raised to minus 2. Whatever is the previous value, divide it by 2. So I am writing it like this. Yes. How do you simplify? We write it as 1 by 2 multiplication and reciprocal, which is nothing but 1 by 2 into 2. Just now we have seen the example. So 3 into 4 could be written as 3 by 4 raised to 2. Similarly here 1 by 2 into 1 by 2. So 1 square of 1 is 1. So I will keep this as 1 as it is, and here I will write 2 raised to 2. Okay. By the same pattern here, 5 raised to minus 2, whatever is the previous number, divide it by 5, which will give me 1 by 5 into 1 by 5, which is nothing but 1 upon 5 raised to minus 2. So, from these two examples, we come to know the second law of exponent, which says, see, when the exponent power was negative and you shift that number to denominator, the power became positive. Similarly here, 2 raised to minus 2, the exponent power was negative, and when this 2 was shifted to denominator, the power became positive. 5 raised to minus 2 shifted to denominator, power become plus 2. Okay, so the second law says, if I wanted to write in a generic way, a raised to minus m, the base, the exponent which is negative, if I have to make this exponent positive, what I have to do? I have to shift this a to the denominator. So it could be written as 1 upon a raised to plus m. Okay, you can write its inverse also. Suppose a raised to m is my original number, and if I shift this to the denominator, this positive will become negative. So if the exponent is negative, after shifting to denominator it becomes positive. If the exponent is positive, after shifting it to denominator it becomes negative. So this is the way of writing it, because we cannot find the value of a number whose exponent is negative. What is the value of 2 raised to minus 2? Yes, you can find the value of minus 2 raised to 2. Minus 2 raised to 2, I can find its value. So minus 2 into minus 2, which gives me plus 4. But for finding the value of 2 raised to minus 2, we cannot find its value until and unless you make the exponent positive. So the first step says, if you have to find the value of an exponential number whose exponent is negative, first of all try to make that exponent positive and then you can find its value. So this number I could write it as 2 raised to 2 and then I could write its value as 1 by 4. Directly I cannot find its value until and unless I make the exponent positive. So this becomes the next law, and hence we can also say that a raised to minus m is multiplicative inverse of a raised to m. Now what is a multiplicative inverse? Multiplicative inverse means whenever you are multiplying two numbers and you are getting the result as 1. So they are saying a raised to m is multiplicative inverse of a raised to m. It means if I multiply a raised to m and a raised to minus m, I will be getting an answer 1. Let us check. This a raised to minus m could also be written as 1 upon a raised to m, and hence I am getting the answer as 1, and therefore a raised to minus m is called the multiplicative inverse of a raised to m. Similarly, you can also read it as a raised to m is the multiplicative inverse of a raised to minus m. Why? Because if you multiply these two numbers, you will be getting the answer as 1, and hence it is called as multiplicative inverse. Okay, so now let us see few laws of exponent. The first law says, suppose I am taking one example as 2 raised to 3 into 2 raised to 2. Okay, so I have to find its value. How I can write it? 2 raised to 3 could be written as 2 into 2 into 2, whereas 2 raised to 2 could be written as 2 into 2. As you can see, the same number is being multiplied with itself. How many times? 2 raised to 5. Yes. Why 2? Because the 2 is the base or the number which is being multiplied with itself. Why 5? Because the number is being multiplied 5 times. So from this, if I try to compare these two, I can say when the base was same, they have done the addition of the index. 3 plus 2 is 5. Yes. and the base was 2 into 2. If the base was something like this, how could you have solved this? See, for such example you cannot write it like that. So 2 raised to 3 into 3 raised to 2. So it will be 2 comes 3 times, whereas 3 comes 2 times, and I cannot further simplify it. Yes. So if you compare these two example, you can see only when the base was same and there was a multiplication sign, I could add the index. Why multiplication sign? Because in an exponent we are multiplying the number with itself. So if you are multiplying more times the same number, definitely that will get added to your index. Yes. So this becomes your first law of exponent, which says if a raised to m is multiplied with a raised to n, the base are same, right? And there should be a multiplication sign between the two numbers, because for division there is a different rule. So we will be first looking at just for the multiplication. If the base are same and there is a multiplication sign between the base, then you add the index, writing the common base raised to m plus n. Okay, base same, multiplication sign m plus n. Let us see what happens when you take division. So 2 raised to, now let us see the next law. Suppose I have to divide 2 raised to 3 with 2 raised to 2. Okay, so 2 raised to 3, how it could be written? 2 into 2 into 2, how many times? 3 times, divided by, hence in the denominator 2 square, so it will be 2 into 2. What is the final answer? It gives me just 2. So compare these two terms. What you can see? Since the base was same, hence they could get divided by itself, right? If the question was like this, I could have written it 2 into 2 into 2 divided by 3 into 3. Now in this case, I could not divide any term with itself, right? Because both are the prime numbers. But when the base was same, I could divide them. But what happened to the index? What did I get at the end? 2, nothing means there is 1. Okay, 1 means what? 3 minus 2. Why 3 minus 2? Because in the numerator it was 2 raised to 3 and in the denominator it was 2 raised to 2. So this becomes your next law, which says if the base are same, a raised to m, a raised to n, index could be different or index could be same. That is not an condition, but the condition is the base has to be same with division sign between the two numbers. In this case, your answer will be a raised to m minus n. That is, there is a subtraction of index. Yes, a raised to m divided by a raised to n gives me a raised to m minus n. Let us compare these two laws. Base has to be same. When there is multiplication sign, index gets added. Base has to be same. When there is division sign, the index gets subtracted. How? Just now we have seen with the help of the example. Because when you are dividing, you are actually cancelling them out. Hence, the number of index would get reduced. But when you are multiplying, the number of times the number gets multiplied with itself increases, and hence the index gets added. Okay, let us see the next law. 2 raised to 3 raised to 2. How could I write this? It means 2 raised to 3 has been multiplied with itself how many times? 2 times. 2 raised to 3 could be written as 2 into 2 into 2 raised to 2. This whole bracket has to be written how many times? 2 times. Write it. 2 into 2 into 2 into 2, 2, 2. How many times? 6 times. So in an exponential form it will be 2 raised to 6. Comparing these two terms, what you can see? The 2 was the base, so definitely the base will remain same. But what happened to the index? this 3 and 2, and here it is 6. So what happened to the index? The index got multiplied with itself. 3 2s are 6. Yes, because this bracket was being repeated how many times? The times it was written in the power. Okay, so this becomes your next law, which says if a raised to m is present and you are taking its nth power, so a raised to m raised to n 2 times, a raised to m is being multiplied with itself how many times? N times. So if I have to write it in simplified form, the base will remain same, and in such a case the index will get multiplied with itself, and hence I could write a raised to m into n. Why? Because this number is being multiplied with itself how many times? N times, and hence it is m into n. Okay, next one. Now here we have seen that if the base were same and the index were different, then we have done addition when there was multiplication between the bases, and we have done subtraction when there was division between the bases. But what if the base are different but the index is same? Suppose 2 raised to 2 into 3 raised to 2. Okay, how this could be simplified? 2 into 2, 3 into 3. What if I take these two terms together and these two terms together? Can I write it like this? 2 into 3 and 2 into 3, which tells me that this complete term is written how many times? 2 times. So can I write it like this? 2 into 3, how many times? 2 times. Again compare what we have done, what we can see, when even though the base were different but the index was same, we have written the common index for that respective basis. Yes, 2 to the power 2 into 3 to the power 2, base were different, index were same, write the bases together and write a common index for both of them. Okay, by simplification also we have seen why this is possible. So this becomes your next law, which says if a raised to m into b raised to m. See here what it was a multiplication sign. Okay, so keep that in mind. So the base were different but the index are same. What we can do? We can write the base together in one bracket and the index to be the common index. For the division, let us see what happens. Again 2 raised to 2, 3 raised to 2. How could I write it? 2 into 2, whereas 3 into 3. If I take these terms together and this term together, can I write it like this? 2 raised to 3 into 2 raised to 3, which tells me this 2 by 3, which tells me this 2 by 3 is being written how many times? 2 times. So can I write it like this? 2 by 3 raised to 2. Yes. So again the base were different but their index was common. Whatever it is, whether it could be an multiplication or division, you can write the bases together and write the index as a common index. If they are into multiplication, write multiplication between the bases. If there is a division, then write division between the bases, and just you can write the common power. So the next law says if a raised to m divided by b raised to m is there, base different, index same, I can write the base together. Since they are into division, I will write them into division, whereas the common power I could write it like this. A raised to m divided by b raised to m gives me a by b raised to common m. Okay, so these are the laws with respect to exponents. The first law, anything raised to 0 is always 1, hence a raised to 0 is 1. A raised to minus m, if we shift this numerator term to denominator, the exponent becomes positive. Similarly, if there is a positive term in the numerator, after shifting to denominator, it becomes negative. a raised to m into a raised to n, base same, index different, multiplication sign, index get added, base same, division sign, index get subtracted. The condition is not necessary that the index has to be different. Even if the question is like this, 2 raised to 2 into 2 raised to 2. Here the base are same, also the index are same. I can write it as 2 raised to 2 plus 2, which is nothing but 2 raised to 4. Okay, so the condition is applicable only with respect to base. The base has to be same. Index could be same or different. Similarly, if a raised to m to the n to the power n, so raised to, if 2 times raised to is there, the index gets multiplied with itself. Next law, base are different but index is same. Write the bases together. If they are into multiplication, put a multiplication between them. If they are into division, write them in a division form and write their common power together.